Wait. Yes. So if we were to use instantaneous center, okay. When to apply instantaneous center, if and only if you are very sure about the what? Velocity vector. This case we are very sure. So we know that this will be coming down. This is your VA. And this will be going in this direction. Right? This will be your what? Over here, this will be your VB. So we are very sure with these two directions. So we know we can construct a line. And this line over here will run horizontal. Now the other line, right, will run in this direction. So we have found our position of our instantaneous center. Okay, so this point over here is our instantaneous center. Now, I'll use this technique also, okay? Because when I taught this section, instantaneous center was not taught yet. Okay, let's do it. So the next thing that you need to know about instantaneous center is you need to know your angles. So we are very sure that this is how many degrees? 45. Right? If that is 45, this has to be what? 45 degrees. Then we know that this is what? This is 90 degrees. Do we know this angle over here? $45. Do we know our angle down here? Do we know this angle theta 1? Why this is important? Because we need to find the distance to the instantaneous center. Do we know what is theta 2? Can someone see something that I don't see? Hey? So if theta is 45, this angle, do you all agree that this angle has to be 45? Yes. Okay. What is theta 1 equal to? Can someone tell me? Wait. Wait. Do we know what is this angle over here? Yes. So theta 1 is equal to 360 minus 90 minus 90 minus by 45 minus 60. You agree with that? So it's 75 degrees. Am I right or wrong? Yes. So this is 75 degrees. If that is 75 degrees, 180 minus 75 minus 45, this is 60 degrees. Okay, let's try it out. I'm getting excited. I'm not going home tonight. If you want to go home, you go home, okay? So we have sine 60 sine 60 over 5. And this is equal to sine 60 over 5. And I'm going to do sine 75 over R, not R, over AIC. So AIC is equal to sine 75 divided by sine 60 multiplied by 5. Okay. So sine 75 divided by sine 60 times 5 is equal to 5.577. Feet. So omega AB, so we know that V what? VA is equal to omega ICA or AIC multiply by R AIC. So VA is equal to 6, right? Omega AIC is what we're going to find out. RAIC is equal to 5.577. Omega AIC is equal to 6 divided by 5.577. So 6 divided by 5.577 is equal to 1.08 radians per second, and it's correct. Okay. So it's working out the angles. Okay. Once you have the angles, then yeah, you are good to go. If you don't know the angles, that's where the problem is. Okay, so now we know this is going in this direction. Now, the next one, we want to find the angular velocity of, we found the angular velocity of the bar. The next thing we want to find is the velocity of the roller B at this instant. Now, this is a pretty tricky question. Why is that? There are two things that we could do. Yes or no? One is to apply, you guys just put me in a rabbit hole. You can apply VB is equal to VA plus by omega AB cross R B from point A. Am I right? Yeah. So yes or no? Yeah, you will get the same answer if you were to do differently from the what? Yes. Yeah, I know. But someone asked me, okay, Eugene, can we solve this using instantaneous center? And I just say yes. And while doing it, yeah, isn't it obvious that you could? Okay. Okay. So you all want me to go further? Yes. No. In the test, what I will do is I'll tell you what to use. Okay. But you know what? If you are not sure of your answer and you're more like if I ask you to solve it in a particular way, and if you're not sure of your answer, you can check with this, right? The answer will be absolutely the what? The same. Are we clear? Okay. So do you all want me to go further or you're comfortable with this? Yes. Okay, do the nonsense then. Okay. Hey? Okay. So I'm going to solve this by not being creative. Okay, I'm going to solve this by not being creative. So we are not going to use the instantaneous center. We're going to use, what technique was it that you said earlier? Yeah, absolute motion. So we're going to use absolute motion. So the absolute motion method is you have to differentiate. Am I right? Differentiate or integrate? Differentiate, okay. So if you look at this problem, at point A and point D, right? So what we can do is, how do we relate motion at point A to point B? Okay. The only thing that we are given, okay, given theta and VA. Okay. So now I'll start constructing lines. Okay, I'll draw green lines. Okay. So I'm going to call this my point D. And I'm going to construct another line over here. And I'm going to construct a line across. Okay. And we know that the line that I'll draw, maybe this is not a very good representation. Yeah, this is better. We know again, I'm going to construct another line. Okay. So where it intersect over here, I'm going to do it. Now, why did I do that? Okay, why did I do that? Because I know this angle that is equal to what? 30 degrees. Okay, we know that angle. So we only know theta and we only know BA. So the next thing that we have to do now, okay, we know that line, wait, we are aware that line AD and BD, right, can relate point A and B, right? What do I mean by that? This distance